Plot PAT for me, triangle PAT. You're just going to start seeing today, we're not going to be dealing with some quadrilaterals sometimes on these coordinate proofs, and that's fine. That's fine. No new formulas needed. Okay, everyone's got triangle PAT. All right, it's not a quadrilateral. We're not proving a rectangle, rhombus, trapezoid. I want to prove an isosceles triangle. We have enough information to do that. What do you know about an isosceles triangle first? What's so great about it? Let's start 15, isosceles triangle. What one big fact? Two sides are equal. So that's what you need to show me right now. Two sides are equal. What formula am I going to need then if I'm going to show you two sides are equal? 9? Which one? Two sides are equal. If two sides are equal. Distance formula. And this is the great thing about graphing it. You guys could probably tell what two sides should be equal, correct? All right, so it's probably going to be finding the distance of PA and then finding the distance of AT. And hopefully they come out to be the same. All right, you know the deal. Work within your group. Let's go. I'm going to come around and actually not sit with every group, but hover around to make sure we're talking about it. So distance of PA, distance of AT. Distance formula, something we've used over and over again. Here we go. 22. What's one distance that you got?
130 for PA.
Square root of 130, everyone. No need to break that down or write the decimal. So you should have got the square root of 130 for both of them. We got to go over any of the math, how to get to 130. Square root of 130. You should have gotten 11 squared and 3 squared on one, and then 7 squared and 9 squared on the other. Gives you 130 for both. All right, keep moving. You know my next step is always, what did we learn? What did we just figure out by doing the distances? PA, please don't put its isosceles yet. PA congruent to AT because distances are equal. And then finally now, we can say that triangle PAT is isosceles. And then somebody just tell me why. Why is PAT going to be isosceles? In your own words. PAT is isosceles 17 because? Look at the work we just did. How do I know it's isosceles now?
Because an isosceles triangle has two congruent sides.
There we go, because two sides are congruent. Okay, any questions about that one? All right, now we got part B, and this is, I know for a fact, is a struggle for us. All right, this is a struggle for us. Find a missing coordinate. So find point R, so when I do PART, it's a parallelogram. Okay, this is a struggle for us. Where should I put point R, so when I connect it with A and T, it becomes a parallelogram? All right, easiest way to do this. Easiest way to do this. What do you know about opposite sides of a parallelogram? They're congruent, and also more importantly here, they're parallel. So opposite sides, if they're parallel, should have the same what formula? Slope formula. So that's what I'm going to have you do right now. Can you guys just quickly in your group find the slope of PA for me? I'm not going to write it down. It's not part of the proof. But find the slope of PA. Up and over how many? Anybody have it? Slope of PA, up and over how many? Up 11 over 3, and it's negative, right? Okay, so guess what? Wherever you put r, TR also has to have a slope of negative 11 over 3. So where do you think I should start counting up 11 over 3 from now to find point R? Point T. Yeah, that's all it is to it. Make sure the slopes match. So everyone start at point T here with me. Go up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and over. 1, 2, 3 to the left because I need a negative slope. And there you go. There's point R. All right, 9, 2, point R. Perfect. Everyone all right? Just make sure the slopes match. Whatever you do on one side, do it to the other. We're all good? All right, now part C. Finally, let's show it. It is a parallelogram now. Prove to me it's a parallelogram. Can we make a class decision? Do you want to do distances or slopes here? Everyone's doing slope? Fine with me? Fine with me. I'll go with the crew. So, all right, go ahead. I'll give you guys another couple minutes. We're going to find the slopes of all the sides now. And hopefully get two pairs that are equal. So slope of AR, slope of PT, slope of AP, and the slope of RT. Go right ahead. Over 6, yep. If you want to reduce it down to 2/3, be my guess. Positive 4 over 6 or 2/3, that's fine. And then here we go, step 5. Tell me what you just learned, right? What did we just learn by doing all 4 slopes? Let's hear from 12. What did we just learn here? Not here. 18, what did we just learn? There you go. AR parallel to PT, and AP is parallel to RT because slopes are equal. And then I think we're all set, right? Step 6, part is a parallelogram. And the only thing I'm going to need and ask from somebody is why. Part is a parallelogram because, based on the work we did, why is it a parallelogram? Hey, 20. Yep. Boom. Any questions from you guys on that one? Not too bad. Even though I asked for an isosceles triangle, we still need a distance. That's not going to change. All right, let's keep rocking. A little change up now. You guys look at it and you're like, uh-oh, he's going to make us do a trapezoid. Nothing to do with the trapezoid here. What I'm going to do is we're going to actually make a new quadrilateral inside ABCD. All right, we're going to make a new one inside, and we're going to call it Mnpq. How do you find M, N, P, and Q? You take the midpoints of each side. So M will be the midpoint of AB. N will be the midpoint of BC. P will be the midpoint of CD. And Q will be the midpoint of AD. So I need to find those points first before I can figure out what this quad looks like. So go ahead in your groups, little midpoint formula, back at it. Find those first 4 points, and then PQ. Find the midpoint of all 4 sides for me. Yep, little midpoint review once again. Here you go with the coordinates. Just check your coordinates. M should be negative 5, 5. N should be 0, 3. P, 2, negative 4. and Q, -3, -2. And if you haven't done so already, go ahead and graph those on your quadrilateral ABCD. All right, I want to start talking to you guys about working smarter, not harder. All right, working smarter, not harder on some of these proofs. Now, part A says, all right, prove that's a parallelogram. And look, we just did it. So if I ask you guys the question, I'm assuming your response is going to be, let's do slopes. That might not be the smartest idea here. Or it's an okay idea. Let me put it that way. I don't want to say it's not a dumb idea. It's a fine idea. But take a sniff at what we have to do for part B. What do we have to do for part B? Prove it not a rhombus. How are you going to do that? Probably show all sides aren't equal by using what formula? So instead of just doing 4 slopes and then 4 distances, 8 formulas total, what do you think's probably the best way here to do a parallelogram? Just do 4 distances and call it a day. Everyone agree? Now look, if you want to do 4 slopes and 4 distances, that's fine. But I know many of you pretty well in here. And however the shortest distance possible, do it that way. All right? The less work you guys need to show, the better. So does everyone see why I'm going to do distances to show it's a parallelogram over slopes? Because I see proving it not a rhombus coming up, and I'm going to have to do distances anyway. All right, so you and your group, Mn, distance of Mn, distance of QP, distance of NP and MQ. And then these are the only 4 you got to show.
Okay, no, just longer.
How are we doing finding these distances? How about Mn and QP? Square root of 29. Take a look. Square root of 29 for Mn and QP. And then we go to NP and MQ. That would be the square root of 53. No need for decimal versions. Just keep it just like that. I can tell they're congruent just by the number underneath. Now remember, part A said prove it's a parallelogram first. Let's talk about that before we go to a rhombus. So step 2, Mn congruent to QP and the other 2 sides, NP congruent to MQ. Because distances are equal. I think it's a parallelogram now. Mnpq is a parallelogram. Because in this case, it's not opposite sides parallel, right? In this case, it would be 23. Why isn't this a parallelogram?
Opposite sides are congruent.
Done. Because opposite sides are congruent. And now look, you don't have to do more work. You just got to write a sentence now. You don't have to do 4 distances now because you did 4 slopes at the beginning. Do we know it's not a rhombus? Yeah. I don't need to show you any more formulas. They're right up there in step 1 if you want to see them. So Mnpq is not a rhombus. And let me know why. Why is it not a rhombus? 20, why is this not a rhombus? Sides are parallel.
No, all sides aren't congruent.
You can thank your group for that. All sides are not congruent. Just remember the test isn't going to be a group test, though. All good?
Yeah.
So sometimes might work smarter, not harder, right? Look at what you have to do later on in the problem. And then we got one more. This one, we'll see how long this one takes us. Could be real short or pretty long here, depending on you guys. All right, go ahead, graph it. We got to show it's a right triangle. I know we haven't done this before, but it's okay. You have more than enough knowledge to complete this. If this is going to be a right triangle, what does it have to have in it? A right angle. Now look at your diagram. Probably where's that right angle going to be? At angle B? Probably. All right. So at least we have a starting point. So let's start thinking formulas we're going to need to show a right angle. Formulas? Slope formula. All right. Do we need to do slope of all three sides? Nope. Just where we think the right angle is going to be at AB and BC. So go ahead real quick, you and your group. Let's find the slope of AB and the slope of BC. Hopefully they won't be equal, but they will have a relationship when you find them. Quickly make sure you all match. All right, back to you guys. AB should be positive 1. BC, negative 1. Not the same. I hope they weren't because I was looking for parallel. But what's negative 1 and 1? Those are negative reciprocals. Perfect. So what do I know then about AB and BC if their slopes are negative reciprocals? Oh, 17. What do I know about the two? Because they had negative reciprocals?
Oh, no.
If two slopes have negative reciprocals, the lines are not parallel. And also think about it. We're trying to get a right angle there too, Emma. So the lines have to be what? If I get a right angle there.
Linear pairs.
Okay, I'm looking for perpendicular here.
Oh,
Perpendicular lines form right angles, right? Linear pairs is supplementary. That shouldn't even come out of the mouth. All right. AB and BC are perpendicular because slopes are negative reciprocals. And now this almost is almost like a version of your statements and reasons. I said the lines were perpendicular. Now what do I usually tell you? If you know the lines are perpendicular. Now I say I have right angles, right? Angle B is a right angle. Because perpendicular lines form right angles. All right, great. Is it a right triangle? All right, that's what I needed. So ABC is a right triangle. Triangle ABC is a right triangle. How about a good reason here for me? Good reason why it's a right triangle. Come on, don't get too serious or complex on me here. Nice and simple. Why is it a right triangle? Ooh, 21. Why is this a right triangle?
Right angles form right triangle.
Right. I'll kind of reverse it there, Scott. Right triangles have right angles, but yours is fine too. Write it down. Right triangles have right angles. Okay, here's where you're starting. We're starting to review right now. All right, for next Tuesday, right now. And then tomorrow is review again. Monday we get back is review. So really 2 classes and 10 minutes of review here. You guys have the pages, the packet, numbers I want you to do in the review. All right, I don't think the page numbers match up. I think it actually starts on page 54 when it says 53, 54, but the numbers all match up. So those are the numbers you're doing. Answers, like usual, on classroom under homework answers. All right, let's get going, and let's put away the other classwork, because that would be great if you guys did math in other classes, but I doubt you do, so don't do other classwork in mine. Here we go. Again, answers are still on classroom under homework. Still all there. This is all review now.